The future of driving and modern transportation are upon us, as autonomous cars are being developed right now by companies such as Tesla, Renault, and many more. Autonomous cars or self-driving cars are cars that are capable of sensing its environment while driving safely with little to no human control. By having a variety of built-in sensors such as radars, lidars, and GPS to help perceive their surroundings, these smart cars are programmed with advanced control system to intelligently navigate to their destination, able to stay in a lane and make decisions to switch lanes, and even able to detect blind spots. But even with all of these technological advancements, autonomous cars still have ways to go and room to grow. That being said, this project proposes mobile apps as a means to control and navigate autonomous cars. While mobile apps, firstly, mobile apps makes interaction between users and car system easily accessible and simple to use, especially for disabled people. Next, given that the mobile app has access information of overall car system, users are able to monitor their car's status anytime, anywhere. For example, users are able to check their car fuel, their tire air pressure, and even track their car during navigation. Currently, there are not many mobile app controlled autonomous cars yet out there, as companies are more focusing on perfecting and enhancing autonomous aspect of the vehicle. However, there were many projects that do focus on mobile app control on small robot cars. Most of these robot car projects found in research articles use Arduino microcontrollers as data processor, ultrasonic module and camera as the robot's main sensor, and are able to control the robot car through their mobile apps via Bluetooth. I need to mention about Nintendo's latest gaming experience, Mario Kart Live Home Circuit for Nintendo Switch consoles, as it shares a similar concept. Essentially, players control a remote control car using a Nintendo Switch with a live feed being displayed on the console screen. A camera situated on the top of the car or cart delivers that feed to the player's screen, while the console displays visual game elements such as bonus items and side obstacles. In this project, my approach is to develop a simulation of an autonomous robot car controlled using mobile apps. The reason I'm doing simulation is because simulation gives freedom for users to personalize and customize every situation to their needs, thus able to experiment with different models at different environments with using different input values. Simulation also allows room for trial and error and repeated testing without worrying real-time risk. This is important as it provides developers with practical feedback when designing real-world models. For my approach, the first step, also the easiest step, is designing the 3D model of the robot car and its environment for the robot car to drive around. The robot car will be equipped with a sensor and a camera, while the environment is big enough and have present obstacles to test the robot car's autonomous driving. Using ROS or Robot Operating System as a bridge to control the robot car along with other sensory node packages, the next step is to manually control the robot car to scan and map the entire environment course to create a 2D map like a building footprint. This process is called G-mapping. Then comes the autonomous driving part. By using the created 2D map and applying certain algorithm packages, a goal destination can be set, while the robot car, using its sensors and its current position, will create a route and move towards the goal autonomously, avoiding obstacles along the way. Finally, I will create a server through my PC so that I will be able to send commands from my mobile app to the robot car simulator. For the expected outcome of this project, I will have a finished mobile app able to access and control the robot car in my PC. Finally, for navigation purposes, the mobile app is able to register checkpoints inside the simulation environment and users are able to command and the robot car to drive autonomously to a selected checkpoint. Thank you.